The world of tomorrow and the instruments of science which are shaping it may seem remote and fantastic, but yesterday's fantasies are becoming today's facts. How will these great advances influence and benefit our personal lives? Here in this science factual film is an answer. Sweeping through an eternal vacuum, through blazing heat and bitter cold, exposed to mysterious radiation, man-made satellites circle the Earth. Traveling at fantastic speeds, these eyes in outer space give us knowledge for future exploration, and also vital information that will lead to a better understanding of one of nature's great forces, the weather. With awesome violence and destruction, the weather is one of man's oldest and mightiest adversaries. But in its ever-changing moods, the weather brings us beauty. The weather gives us our daily bread. The weather makes possible all living things. And the weather certainly influences our daily lives. Yes, we have always been at the mercy of weather. When the weather is nice, we are happy. If the weather is hot and muggy, we tend to be frustrated, irritable, and even criminal. But if the fog rolls in, we are apt to be depressed. Thunderstorms cause fear and apprehension. Icy winds and snow seem to slow us down. In trying to predict these capricious changes in weather, we sometimes resort to rather questionable weather forecasting devices, such as an almanac, a crystal ball, a gouty leg, and the law of average.
April showers bring May flowers. When mule ears shake in a certain way, it means that rain will fall that day. If a spider you should slay, rain will fall within a day. It's a sign of rain and snow when the birds and bugs fly low. As the weather is on New Year's Day, for 30 days 'twill stay that way. As the weather is on January 2, for February and September the same holds true. As the weather is on January 3, so the last 3 months of spring will be. As the weather is on November 21, so the coming winter's one. One is one, winter's one. So, as the coming winter has a New Year's Day, and if the fine weather holds its sway, the weather is bound to stay that way forever, ever, and a day.
Well, no matter how we try to predict the weather, of this we can be certain. It will always be with us. To understand it, let's look into any ocean, lake, pond, or puddle. Here in this watery world, cool and calm as can be, lives this damp little drip floating peacefully. But when the heat's on, the sun comes out. The rays, they agitate him, make him jump about. Well, he gets all shook. Look out, stand back. He's going to blow his stack. The drip evaporates, and then he's joined by his friends. They're together again. They float up high on the moist, warm air. We can't see them, but they're still there. They fly way up where the cold's intense, then back into droplets. They condense, and that's what makes a cloud. But when too many droplets crowd a cloud, that crowded cloud, he cries out loud. That's the way we get the rain. Well, look who's here, the little drip again. Back in the puddle. Hot skies. Drops rise. Vaporize. Liquefies. And that's what makes a cloud. Sometimes these droplets blow up high, higher and colder, colder. Why, they get so cold they crystallize, and snowflakes form in those frigid skies. Then they fall into warm air, melt into rain. Well, look who's here. Yep, the little drip again. Back in the puddle. Heat. Beat. Rise. Skies. And that's what makes a cloud. This time those drops are blasted high. Still higher, still colder. Look at them fly. One turns to ice, and others stick to it, getting bigger and bigger. Look out! I knew it! It's way too heavy! It's falling! Wow! The little drip's a hailstone now. He's back just where he was before, and the whole thing's ready to start once more. This constantly repeating cycle of weather may seem capricious and without direction, but throughout nature there is order. Weather is a constant blending of the basic elements: air, water, and sun. It all starts with the sun. This tremendous white-hot ball of gas, 750,000 miles across, supplies the power that drives our weather machine. The sun is a gigantic atomic furnace, consuming itself at the rate of billions of pounds of matter per second. Across its boiling surface drift mysterious spots. Solar flares surge in flashes of raw energy. Writhing, flaming clouds of incandescent hydrogen gas explode hundreds of thousands of miles into space. The sun is absolutely essential to life on our planet. Our Earth is surrounded by an envelope of air. Radiant energy, constantly pouring out from the sun, heats the Earth and its atmosphere unevenly from pole to equator, setting in motion broad flowing rivers of air. Wherever opposing currents of air develop, giant eddies and whirlpools are formed. These are traveling areas of low pressure in the atmosphere. The clash of these opposing air streams causes clouds to form and usually brings stormy weather. Between the areas of low pressure, there are eddies rotating in the opposite direction. Here, air pressure is high. This usually brings clear skies and fair weather. By charting their positions each day, weathermen can estimate the course they will take and the weather that will result. Keeping track of the steady parade of storms and fair weather requires the constant preparation of new maps. This is a never-ending task. Weathermen must construct these maps from a continuous flow of data that pours in from weather stations all over the world. In remote, isolated areas, in crowded cities, in high-flying aircraft, and in ships at sea, modern weathermen depend on a variety of specialized instruments to gather information. They measure temperature, moisture, air pressure, and wind speed. Balloons carry instruments aloft, automatically radioing back information. New radar techniques locate and track storms. And modern electronic computers now play an important part in weather forecasting by their ability to store and rapidly process vast amounts of data. But today, we are just beginning to understand something of the forces behind the weather. Scientists realize they must search in many directions and ask countless questions. For instance, can future weather be predicted by looking at the past? Does the slow advance and retreat of glaciers over periods of centuries indicate cycles in the Earth's climate? Past records of bird and animal migration, or the migrations of man, may furnish clues. And even ancient tree rings give an indication of wet and dry periods. The vast unexplored polar regions of the Earth pose another kind of question. What effect do these frigid areas, covering millions of square miles, have on the weather of the entire world? Auroras, the ghostly lights that flicker in polar skies, tell something of what happens when energy from the sun plunges into the sea of air that surrounds the Earth. Adventurous scientists are probing the atmosphere itself, climbing to incredible altitudes in their search for knowledge. New scientific tools are being used, rockets launched from balloons, and rockets launched from the ground carry instruments higher and higher. Unfortunately, these flights last but a short time, and only a small amount of information can be obtained. But now we have more advanced scientific devices for gathering data continuously over long periods of time, not only from the atmosphere, but from space beyond. Artificial satellites. Satellites reach into the unknown with instruments that duplicate man's own senses. The eye of the satellite is a photocell or a radiation counter. Its ear, a tiny microphone. Its memory, a tape recorder. And its voice is a radio transmitter. Here, these instruments are placed in an actual weather satellite, designed to record the cloud formations covering the Earth. In this cross-section view, we see how all the instruments have been reduced to an amazingly compact unit weighing but a few pounds. Here is one of the electronic eyes of the satellite. This eye converts the light reflected from land, ocean, and cloud into electrical impulses. These impulses from the eyes are changed into electronic signals that are recorded by this tiny tape machine. Recording continuously for periods of nearly an hour, this incredibly small instrument remembers everything the weather satellite sees. Triggered by a radio signal from Earth, the recorder plays back the stored information in only 1 minute. These precious reports on the Earth's cloud patterns are received by specially designed stations on the ground. The radio signals from the satellite are now converted back to a moving pattern of light on the oscilloscope, and finally translated into a picture of the cloud formations the satellite has seen during one trip around the Earth. Today's weather satellites are small and are designed to do a limited job. However, they are the first step forward to larger and more versatile space explorers of tomorrow. These future satellites will be the key to precise forecasting and control of weather. Let us project our present knowledge with imagination and speculate on how satellites might be used in future operations from a worldwide weather center. This is the master control room. Electronic maps and view screens display up-to-the-minute pictures of the weather around the Earth. Every hour, reports are automatically received from all points at sea, on land, and in the air. 22,000 miles out in space, 3 robot satellites train their sensitive television eyes on all parts of the Earth. These pictures are monitored on viewing screens in the Weather Center. Here in the computing room, electronic machines digest the constant flood of information received from all stations. This is then translated into an ever-changing diagram of the Earth's weather. Forecasts for every sector of the globe are made months in advance. Prediction charts have indicated that a powerful hurricane will begin forming today in the Atlantic Ocean. The electronic weather map shows an intense storm system building up about 1,000 miles due east of Miami, Florida. The controller calls for a close-up satellite view of the troubled area.
Coco 526, Yankee 2.5.
Okay, controller, Coco 526, Yankee 2.5.
The characteristic swirling clouds of the hurricane are beginning to form. At sea, the waves anticipate the violence to come. The controller calls for a last-minute prediction of the hurricane's path. If control measures are not begun at once, the hurricane will smash across densely populated areas within 48 hours.
11 a.m. EST. A hurricane is forming 960 miles east of Miami, Florida. If control measures are ineffective, it will pass inland at Cape Hatteras in 48 hours. Control operations will begin within 2 hours, but safety precautions should be completed from Cape Fear, north no later than 6 p.m. tomorrow.
At Weather Central, the control strategy is mapped out. A ridge of high pressure slants across the eastern United States between 2 low-pressure storm systems. If these 2 storm centers are intensified, the high will build up along the coast, forming a barrier that will turn the hurricane out to sea.
Stand by. Now pulling in satellite number 1 for visual check of low-pressure systems L20 and L21.
The operator brings the satellite into focus on the 2 storms. One centered over Kansas, the other over Labrador.
Changing to northeastern low, L21.
With the touch of a button, the battle begins. On the ground, chemical cloud seeders begin to work the 2 storm areas. Robot planes seed the clouds from above. The storm centers over Kansas and over Labrador intensify as seeding continues.
Now changing over to Hurricane Center H8.
The fury of the hurricane mounts as 100-mile-an-hour winds lash the sea to a foaming frenzy.
All stations, Sector C. Activate Phase 2, Control Plan Delta. Set vapor rockets for 42,000 feet.
As an emergency measure, the controller calls for a salvo of vapor rockets to be fired ahead of the path the hurricane is predicted to take. These artificial clouds will block the sun from evaporating more water to feed the hurricane. The reports coming into the control center indicate that the diversionary cloud seeding over Kansas is now creating a flood danger. Specially equipped robot aircraft are dispatched immediately to release a high concentration of cloud seeding material into the fringes of the storm. heavier seeding from the ground also helps to subdue the rain by spreading it over a wider area. The controller calls for another view of the hurricane, which has now moved closer to the coast.
Signal out on number 1 satellite. 10-minute interruption for correction. Have you anything else in the area?
Satellite station S1 is approaching area. We'll make contact. S1, this is Weather Central. Request video signal at grid coordinates COCO.
An emergency situation has developed. In an orbiting space station 1,000 miles above the hurricane, a crewman sends a temporary picture back to Weather Central.
Okay, S1, your video is R5S5. Thank you.
The hurricane has stopped moving toward the coast, but is still intensifying. It must be made to move northward and out to sea. This is a crisis.
Aberdeen Station. Activate multiple seeding rockets on course 117.
The controller decides to fire cloud seeding rockets just ahead of the hurricane, hoping to start it moving. Slowly, the hurricane begins to shift. All available forces have been brought into play. Now we can only watch and wait. After hours of tension, the turning point is reached. Latest reports indicate the control strategy is successful. At last, the high-pressure ridge has settled along the coast, forming an invisible wall of safety. The storm is over. The danger has passed. The hurricane has been defeated, turned away from the land, and left to spend itself harmlessly far out at sea. In the world of tomorrow, weather control will enrich and safeguard our daily lives. In the foreseeable future, we will conquer more than violent storms. We will turn the destructive elements of today into new sources of power, shaping the land on which we live. All mankind will benefit. Arid wastelands will be made green and fertile, and vast frozen areas will become productive. To this end, man-made satellites will probe the secrets of the skies. They will be our eyes in outer space.